So we are discussing about the group and the period of a periodic table. So group is representing is a vertical column which represent number of electrons in the last shell, and the period is representing the horizontal rows. That is representing the horizontal rows, or we can also say total number of shells. And this is period 1, period 2, 3, 4, 5, 6, and 7. So we have basically 7 periods: period 1, period 2, 3, 4, 5, 6, and 7. And we have total 8 groups. You can see the Roman number which is written, that is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Which group and period this element gallium belongs to? What is the group number of this element? Group number of gallium. I want everyone to participate. Abdullah Khan, Heather, Hatem, Saim. So it belongs to group 3. As you can see, the vertical column here is 3, so it is group 3. What about the period? Which period it belongs to? So when you want to check, you can check. This is a group number and the period number. So it belongs to group 3 and belongs to period 4. What about the element oxygen? Element oxygen, which group it belongs to? Yeah, that's right. It belongs to group 6. So as you can see, the vertical column. So if it belongs to group 6, it means it is having 6 electron in the outermost shell. And which period it belongs to? So when you check the period in a periodic table, so it is period 2. So using a periodic table, you should be able to work out the group and the period of an element. And mainly for first 20, but you should be able to work out for others as well. But mainly they will ask for first 20. Then how we can work out the group and the period by using the structure? So finding group and period by using the structure of an atom. If we have calcium, which is 20 and 40, what is A here? The nucleon number for calcium. What is A? A is equals to 40. What about Z? Z is 20. Number of protons, that is given by Z, so that's 20. Number of neutrons, which is A minus Z, 40 minus 20, so that is also 20. And number of electrons, that is Z minus the charge, but there is no charge here, so it is 20 minus 0, which is 20. So we have to arrange 20 electrons to draw the structure. So the center, in the center we have 20 protons and 20 neutrons. So I have to arrange total 20. First shell, maximum how many I can arrange? The first shell. So maximum I can have 2. The second shell, maximum how many I can arrange? 8. So with total I have to arrange 20, but so 2 plus 8, that makes 10. So basically I arrange 10 electrons till now. Then I draw the third shell, maximum for first 20 elements. Again it will be 8. So 2 plus 8 plus 8, that makes 18. So out of 20 we have arranged 18 electrons. And the last shell will have 2 electrons in the last shell. So using the structure, what is the group number? Group number means number of electron in the last shell. So what is the group number of this calcium? So it belongs to group 2 because there are 2 electrons in the last shell. What is the period of this element? Period is representing the total number of shells which we use. So 1, 2, 3 and 4 shells are used here. So it belongs to fourth period. So when you write group, it's better you use a Roman. So it is group 2 and period, fourth period. And what is the electronic configuration? What is the electronic configuration of this calcium? So it is 2, 8, 8 and 2. And you can see, you can confirm from the periodic table whether you did correct. You work out group 2 and period 4. So I will check the periodic table whether I did correctly. Group 2, so we work out the calcium from the structure. We work out the calcium and we check it belongs to group 4 and it belongs to period 1, 2, 3 and 4th period. So that's the same thing we worked out from the structure, that it is the 4th period and it is a second group. But there is one exception here. When we are working out the group, that is the helium. For a helium, as we already did in the last session, the structure of a helium, that was 2 and 4. So A was 2, sorry, A was 4 and Z is equals to 2. Total number of proton, which is Z. Number of neutron, it is A minus Z. And number of electron, that is Z minus the charge. So charge is 0 here, that is equals to 2. So there are 2 protons, 2 neutrons, and when we draw the first shell, maximum we can arrange 2 electrons in the first shell, so it is having 2. So what should be the group number here? How I work out the group number? Group number represents the number of electron in the last shell. So how many electrons are there in the last shell? This is the first electron in the last shell and this is the second electron in the last shell. So how many electrons in the last shell, that represent the group number? As there are only 2 electrons in the last shell, that's why it is group 2. And period 1, 2, 3, and 4 shells are used here, as you can see. That's called a period number. So in case of helium, according to the structure, it should be group 2. But that's wrong because it is an exception. It is not, it should be in group 2 according to the concept that number of electrons in the last shell that represent the group number. So according to that theory, it should be second group, but it is not in a second group. It is in the 8th group. But why it is exception? Why helium is exception here? Because in the 8th group, we have elements in 8th group which have complete shells. Yeah, the property, that is the reason. And another thing is there, complete shell electrons, element with complete last shell, are placed in 8th group or also known as 0 group. 8th group is also called a 0 group. So in case of helium, why it is not placed in group 2? Why it is placed in group 8? Because in the first shell, maximum, if we have a first shell, maximum it can have 8 electrons. Maximum it can have 2 electrons. And there are 2 electrons here. That's why it is not placed in group 2. It is placed in group 8. And when you check the helium, you will find the position in group 8. So this is an exception only for helium and hydrogen. Hydrogen we already discussed. For hydrogen it was about the properties, and for helium it is about the complete shell. So helium, according to the theory, helium should be here. According to the theory, helium should be here, but because the structure is complete, that's why it is placed in group 8. Why there are 2 protons? Because the atomic number of helium is 2. That is why it is having 2 proton. Atomic number represent the number of the proton. So if this number is 2, it means there are 2 protons. And every element is having different number of protons. That is the identity of the element. Like hydrogen is having 1 proton. You cannot find any element in the periodic table with 1 proton. Neutron is not represented by 4. This is called a nucleon number. This is the sum of neutron and proton, also known as a nucleon number. So the 2 exceptions, if a question is why hydrogen is not placed in group 1, so if I say why hydrogen is not placed in group 1, so your answer should be its property does not matches with group 1 element, that's why it is not placed in group 1. And why helium is not placed in group 2? Because it is having a complete shell. Because it is having a complete shell, that's why it is placed in group 8 instead of group 2. So these are the 2 exceptions, hydrogen and helium, that not placed in a group according to the theory. Is it clear, this concept? Then we define a term isotope. What is the meaning of the term isotope? Isotope means having same number of, or atoms having same proton but different neutrons. We call them as isotopes. As you can see, this element is having 1 proton, this is having 1 proton, 1 neutron, and 1 proton and 2 neutron. So if the proton numbers are same, it means it will be element, like same element, because the proton number is the identity of the element. So proton number is basically the identity of the element. If atoms are having the same number of proton, it means they are the same. It is the same element. So you can see in this example, these all are hydrogen. They are giving different names, but actually they all are hydrogen. But what is the difference between them? They have different number of neutrons in the nucleus. This is having this is not having any neutron. The other one is having one neutron, and the second one is having two neutrons. So when the atoms have the same number of proton and different number of neutrons, we call them as isotopes. So this is a term which we use to explain that they have same number of proton and different number of neutrons. So if I draw a structure, the pink shade is representing a proton. And the gray shade is representing the neutrons. I'm just drawing the nucleus because for isotope, we just have to check the nucleus. We don't have to check all other elements. So this is the nucleus. The gray shade is, the pink shade is representing a proton, and the gray shade is representing the neutrons. So my question is, are they isotopes? Isotopes means they should have same number of protons and different number of neutrons. That we call as an isotope. So question is, are they isotopes? Yes or no? Nucleus 1, nucleus 2 and nucleus 3. Are they isotopes of each other? So they are not isotopes. And there are they different elements like nucleus 1, nucleus 2 and nucleus 3? So they are different elements. And if I say, can you identify the element? How you identify the element? You check the proton number. Whenever you want to identify the element, you check the proton number. So proton number is 1. So you will check the periodic table, which element is having a proton number 1. Which element in the periodic table having a proton number 1? So that is hydrogen. So basically, the first one is hydrogen. What about the second one? It's having proton number 2. So second one, when you check the periodic table, that is helium. The proton number 2, that is because this number is a proton number. So the second one is actually helium. And what about the third one? And the third one is lithium. So when you have different so these are basically different elements, but they are not isotope. To be an isotope, they should have different number of neutrons, but they should have same number of protons. If I give another example, you have so to check the isotope, we mainly check the proton. This is nucleus A. Yes, Abdullah Sarfraz.
Sir, but lithium is having 4 neutrons, and
Hmm.
in the last slide, I think so, you drew 3 of them.
Hmm. Which one?
The lithium one.
Hmm. So it can be an isotope. That's the point. Element in a periodic table, they normally place, like for a lithium, it is written when you check the periodic table, they write Li as 3 and 7. So for lithium, they write Li 3 and 7. So what does it mean? It means it is having 3 proton, it is having 4 neutron, and it is having 3 electrons. But when we check, it can be an isotope. So isotope is not necessary it will have the same number of neutrons. The neutron numbers may vary in isotope as the normal one. The common one in a periodic table, they give you the common isotope, but natural, like most abundant element or most abundant atom which are existing. But it may have isotope, so isotope may have different number of neutrons. So when you are checking the element, you don't bother about the number of neutron. You always check the number of proton, which is an important thing for identity of the element. Is it clear?
So we only concentrate on proton.
Yeah, when we are identifying the element, we just focus or concentrate on the proton number. We don't bother about a neutron number, because a neutron number might change even the element is same. And when the neutron number is changing, it means it is called an isotope of the element. Is it clear?
Yes, sir.
So when we are drawing, like example, I'm drawing nucleus A, nucleus B, and nucleus C. The gray shade is representing a neutron and the pink shade is representing the proton. First thing, my question is, what is this element? This is a nucleus which contains proton and neutron. So which element nucleus is this, which is having 3 proton? So this is lithium. What about the second nucleus? Which element? That is also lithium. Why lithium? Because both have the same number of proton. Lithium is having, so this is lithium and this is also lithium. So when we have the same element, the third one is also lithium. So when we have the same element but different number of neutrons, so same element but different number of neutron, what we call them? We call them as isotopes. So what we'll use the term, we'll say nucleus A, B and C are isotopes of lithium. Is it clear? So you have the same element, but when different number of neutron, we simply call them as isotope. Is it clear, Sime? That was your question, like example of isotope in a nucleus. So we have chlorine. The term isotope means they have same number of protons but different number of neutrons. So when you have same number of protons and different number of neutrons, you simply call them as isotope. So in the first example, we were having different number of proton. This was having one proton, this is having two proton, this is having three proton. So why we did not say they are isotope? Because they have different number of proton. To be an isotope, they should have same number of proton. As you can see, nucleus A is having three protons, nucleus B is having three protons, and nucleus C is having three protons. And when you check the neutron, nucleus A is having 3 neutrons, nucleus B is having 4 neutrons, and nucleus C is having 5 neutrons. So they have different neutron and same proton. So that type of atoms with same proton and different neutron are simply known as the isotopes. So if you have a structure, how many proton? Here pink shade is representing a proton and gray shade is representing the neutron. How many protons are there in the first one? Nucleus A, B, and C. How many neutrons are there? How many protons are there in A? A is having two protons. How many protons are there in B? Two. And how many protons are there in C? Two. So my question, which element is having two protons in a periodic table? That is helium. So basically, this is helium atom. This is also helium. This is also helium. But when we check the neutron numbers, how many neutrons are there in the first one? The number of the neutron in the first one, there are 3 neutrons. The number of the neutrons in the second one, there are 4 neutrons. And number of neutron in the third one, there are 5 neutron. So they have different number of neutron and they have same number of proton. So we call that A, B, and C are isotopes of helium. Is it clear? So basically the term isotopes means the atoms have the same proton and they have different number of neutrons. Is it clear, Sime? Okay, I'm drawing a different structure and I want everyone to work out the isotopes from the structure. The pink shade is representing proton and the gray shade is representing the neutrons. And I will only draw the nucleus. So these are 5 different nuclei. You have A, B, C, D, E, and F. And the question is, which one are the isotopes? The first question is the isotopes of A. So which one are the isotopes of A? Isotopes of A. So that is C and E, because C is having same proton, and so our correct answer is C and E. That's right. Isotopes of B. Can you find any isotope of B? So there's no isotope for B. And what about isotope of C? C is already, A and E will be there. And isotope of D. So isotope of D. So isotope of D is F. Protons, to be an isotope, they should have same number of proton and different number of neutron. So A is having 2 protons. You can see C is also having 2 proton. E is also having 2 proton. And they have different number of neutrons. So A, C and E are isotopes of each other. And D and F are isotope because they have same number of proton and different number of neutron. Where B does not have any isotope. Is it clear, this example? It's not about number of proton and neutron within the atom sign. We compare with another atom. C is having 2 protons and 2 neutrons. But it's not about comparison within the atom. It is compared with another atom, like A is having 2 proton and 3 neutron. So compared with another atom, they should have same number of proton and different number of neutron. It's not about within the atom. Within the atom, they may have 3 proton and 3 neutron, but that does not decide isotope. It is a comparison with another atom. Then these isotopes can be non-radioactive or it can be a radioactive. So non-radioactive isotope does not emit radiations, harmful radiations, whereas radioactive isotopes emit radiations or energy is released from that. And there are uses about the radioactivity in detail. You will study in physics block 5 that what is the concept of radioactivity. Basically, when some of the atoms they emit out radiation, like atoms are there and there are neutrons and protons. This is a nucleus, and around the nucleus electrons are there. So some of the atoms, some of the nucleus have the tendency to emit out radiation, energy or radiation you can say. So when these nucleus emit out radiation, we call them as radioactive. And some of the isotopes does not have any tendency to emit out radiation or emit out rays. We call them as non-radioactive isotopes. So no radiation are emitted from that. So you have to just learn the use of radioactive isotope. So these radioactive isotopes are used for treatment of the cancer. So there are two types of isotopes and they have the uses, one medical and an industrial use of radioactive isotope. What is a medical use? To sterilize equipment. Sterilize equipment means it's used to kill the bacteria. To, and second thing, as a tracer. Tracer means to if you want to identify any leakage or a blockage, basically mainly for blockage in arteries. So we use them and we call them as a tracer. Industrial use, in industry we use them as a smoke alarm, and it is also used for a tracer to identify the blockage or the leakage in the pipes. You don't have to go in detail of these, you just have to learn the uses of the radioactive isotopes. So isotopes are of two types. One is radioactive, another one is non-radioactive. And for radioactive, there are uses. You have to learn one medical use and one industrial use. So what is the medical use? To kill bacteria. For industrial use, it's used in smoke alarms, or you can also say tracers. Is it clear? Any question related to the class today? In the next session, I will discuss more things about isotopes and then we'll do some questions related to the isotope. So I'll end the session and share this recording. Yes, Abdullah, you have a question, Abdullah Sarfraz? So I'll end the session now and share this with you.